Hello everyone, myself Sai Prasad, Alexa in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started a discussion with all the algebraic chapters here. What did we learn? We learned complex numbers, De Moivre's theorem, and we did most of the problems of quadratic and theory of equations. Right? Fine. Today we are going to start a new chapter which is a kind of completely different from whatever we studied till now. Okay, that is permutation and combinations. What do you mean by this? Permutation is nothing but arranging a given set of elements. Okay, based on different criteria, the condition they give and the condition we have to satisfy, and all those it depends, we'll discuss. Okay, but most of the permutations we are going to discuss have a single formula, that is NPR. Okay, which means n number of elements we have to select for r times. Okay, clear? Or else simply let me tell, there are n elements from which we have to select r elements. Okay, out of n elements we have to select r elements. So the formula is given by NPR, which is n factorial by n minus r factorial. What is this factorial? This factorial is nothing but a simple number. Let us say if it is 5 factorial, we'll write it as 5, 4, 3, 2, 1. Done? Do you understand? Once again, see here, a permutation is selecting number of elements, or simply after selecting and arranging. Okay, we'll discuss everything again, but simply the permutation ka formula mostly we use is NPR, which is out of n dissimilar elements we are going to select r elements, r number of elements. So that is given by NPR, whose formula is n factorial by n minus r factorial. What is this factorial? Let us say if it is 5 factorial, we'll write as 5, 4, 3, 2, 1. Done? Fine. Based on that, we'll discuss most formulas and everything. So what about the combination now? We'll discuss again in detail once we complete this permutations. But what is a combination is, here we discuss about all dissimilar elements irrespective of the other. Okay, whatever we select, it does not depend on other based on the condition and relation. But whereas in the combination we are going to have a combinational sets, so that we have to select and arrange accordingly. This all we'll discuss again. Clear? Fine. Did you understand what is permutation now? Shall we start doing problems on permutations? Let's do. Look at the questions here. He gave NP3 is equal to 1320. He is asking us to find the value of n. And here NP7 is equal to 42 into NP5. And he is asking us to find the value of n. Clear? Remember, just put a kind of notation like P should be in between. 3 is a subscript here, and here n should be like a power on left side. Done? Don't mix everything. See here. What's the formula of NPR? The formula for NPR is equal to n factorial by n minus r factorial. Isn't it? What is n here? The n itself is n, r is 3. So shall we substitute? See here. NP3 is nothing but n factorial by n minus 3 factorial, that is equal to 1320. Done? Now just tell me, what is n factorial? If it is 5 factorial, we will write it as 5, 4, 3, 2, 1. Done? If it is n factorial, can I write it as n into n minus 1 into n minus 2 into n minus 3 factorial? Yes. Yes or no? Once again let me tell you, if I have 5 factorial, I write it as 5, 4, 3, 2, 1. Instead of that, can I write it as 5 into 4 factorial? Yes or no? 4 factorial itself is 4, 3, 2, 1. So instead of writing this whole thing, I will just write 5 into 4 factorial. Clear? The same thing we are going to do here. Instead of n factorial, we will write it as n, n minus 1, n minus 2, n minus 3 factorial. Why? So that we can cancel these both. Right? Now see here. If you can write here you can just multiply and factorize and write the values. Or else let me factorize 1320. What can I write? 132 can be written as 10 into 132 ka factors 12 11s are right, 11 into 12. So if you observe here, this is nothing but 12 into 11 into 10, right? This considers about big number. This is 12 minus 1, this is 12 minus 2. So what is n here? That's it. Since we know that 132 can be written in the form of product of consecutive numbers. So since this is also product of consecutive numbers, we can equate the bigger number on the left hand side to the bigger number on the right hand side. Is it? Fine. If you are unable to understand or how to write this as a factors of this numbers, it would be better if you multiply all these and factorize this cubic polynomial. If you can do, it would be better. Okay, fine. Look at the next question here. NP7 is equal to 42 into NP5. How do we do this? Let us first substitute the formulas. NP7 is n factorial by n minus 7 factorial. That is equal to 42 into NP5 is again n factorial by n minus 5 factorial. Is it right? Fine. If you observe here, n factorial got cancelled. And the next, the left numbers is n minus 7. Let us put it as it is. 42 by n minus 5 factorial can be written as n minus 5. N minus 6 into n minus 7 factorial. Can we cancel these both? Right? Until unless you practice this kind of things, we will never understand where should we stop this factorial. Right? Why did I stop only till this? Because I can cancel n minus 3 factorial. Why did I stop only this? Because I can cancel n minus 7 factorial. Done. So let me cross multiply. I will get it as n minus 5 into n minus 6 is equal to 42. Now just tell me, can I write 42 as product of two consecutive numbers? Just tell the factors of 42. 7 6 are. So obviously this is nothing but 7 into 6 n minus 5 into n minus 6. First is this, second is this. Right? So n minus 5 is 7. Therefore n is 7 plus 5. Obviously n is 12. Is it clear? Anything difficulty you feel here? No, right? But the main thing you have to remember is this formula and writing this single factorial into product of this kind, so that we can cancel the terms. Clear? Shall we move on to the next problem? Let's do. Look at the next thing here. Here we have a formula that is NPR can be written as n minus 1 PR plus R into n minus 1 PR minus 1. This is one simple formula which can be separated and segregated. So by using this formula, let us solve this problem. It is actually very simple if we are okay with the formula. Fine. See here. The question given here, it is 12p5 plus 5 into 12p4 is equal to 13pr. If we can simplify whatever it is there on left side, it's fine. But since here completely it is given like 12p5, 12p4 and all those, let us consider the right hand side. Okay. Just check here. Let me put LHS as it is and let me write 13pr. Okay. Just let us substitute this R ka formula here. 13 instead of n, let us put 13. R is as it is. Can we? Now just see here. 13 minus 1 is 12pr plus R into, again 13 minus 1 is 12p r minus 1. Okay. Now just compare LHS and RHS. Here it is 12p5. Instead of r, if we assume it is 5 plus again it is 5, 12, p, 5 minus 1 is 4. So just simple, instead of r we have 5, that's it. Okay, anything more to discuss? No, right? But we have to understand this formula. Okay, next let us do one more thing here. 18 pr minus 1 is to 17 pr minus 1 is equal to 9 is to 7. Then they are asking us to find the value of r. Okay, this is a kind of ratio. 18 pr minus 1, that is nothing but 18 factorial by 18 minus r plus 1 factorial divided by 17 factorial by 17 minus r plus 1 factorial is equal to 9 by 7. Right? Now let me interchange a by b by c by d can be written as just a cross multiplication, right? So we can write it as 18 factorial by 18 plus 1 is 19 minus r factorial into here 17 plus 1 is 18 minus r factorial by 17 factorial, that is 9 by 7. Okay, now let us simplify that. What do we get? Can I write 18 as 18 into 17 factorial? Yes. Next, 19 minus r can be written as 19 minus r into 18 minus r factorial. Is it possible? Yes. Next, into 18 minus r factorial by 17 factorial, that is 9 by 7. These both will get cancelled. These both will get cancelled. The left out is 18 by 19 minus r is equal to 9 by 7. If possible, we can cancel this also. 9 ones are 9 twos are. So what is left? 19 minus r is equal to 14. So what is r? 19 plus 14. Simply r is, are we leaving something? No, right? What is 19 plus 14? 33. Okay, is it clear? Once again you can see here 19 minus r is 14, so r is equal to 19 minus 14, sorry. So this is nothing but r is 5. Is it simple or not? Once again see here, the question is given as 18 pr minus 1 is to 17 pr minus 1, right? Just I have used a formula. 18 pr is 18 factorial by 18 minus r factorial. Denominator 17 factorial by 17 minus r factorial, right? So just by using the formula and simplifying it, we got the value of r. Clear? These are the basics of how do we solve the formula in PR. Similarly, there are few more problems like sum of odd digit numbers that can be formed using given n non-zero digits. Let us say I have 5 numbers 1, 2, 3, 4, 5. Okay, these are 5 non-zero digits. These 5 numbers, if I want to make 3-digit numbers, so how many numbers can I make? That is the first question. Second, after that, how to add those all numbers, whether it is a 3-digit number or a 2-digit number. Okay, so how do we arrange? How many numbers do you get? And the sum of that is given as n minus 1 pr minus 1 into sum of the given digits. If it is 1, 2, 3, 4, 5, 1 plus 2 plus 3 plus 4 plus 5 like that, into 1, 1, 1 and so on up to how many ones? If it is 3-digit number, I will write as 111. If it is 2-digit number, I will write as 11. Okay, fine. This is if the numbers doesn't include 0. What if the numbers include 0? The same formula is n minus 1 pr minus 1 into sum into 111 and so on up to r numbers minus n minus 2 pr minus 2 sum, and this is one more thing. Clear? Fine. This is the formula which we are going to use in the future problems. But before that, shall we start the actual problems? What? That is, if it is NPR, we will say that we have n items in which r items has to be selected. So the formula is NPR. Shall we do those kind of problems now? Let's do. Look at the questions here. He is telling that a man has 4 sons and there are 5 schools within his reach. In how many ways can he admit his 4 sons in 5 different schools so that no 2 of them will be in the same school? So how do we arrange? We have 5 places, right? And we have only 4 objects. Okay? Out of these 5 places we can arrange this 4 in any one of them. Okay? So what was the formula which we know? If it is NPR, we will have n different items, out of which we have to select r different items. Okay, out of n we have to select r. Here also out of 5 we have to select any 4. So what is the answer here? Directly 5p4. Yes. When it comes to exam, write like number of schools is equal to number of sons is equal to, then the number of ways he can arrange is given by 5p4. Okay, since we can't write everything in the here, I am writing it directly. 5p4 is nothing but 5 factorial by 5 minus 4 factorial, which is 5 factorial by 1 factorial, which is 120. Right? Yes or no? 5. What is 5 factorial? Just tell me. 5, 4, 3, 2, 1. 5 4s are 20. 3 2s are 6. 6 2s are 12, which is 120. Isn't it? Yes or no? Fine. Just have a look, and one more thing I forgot to tell. What is 1 factorial? 1. What is 0 factorial? 0 factorial is also 1. Remember, I am not going to repeat it again. 0 factorial is also 1. Clear? Fine. Did you understand this problem? There is a first theoretical question which we are solving. Yes? Fine. Look at the next question. In a class, there are 30 students. Okay? On a New Year day, every student posts a greeting card to all his or her classmates. Find the total number of greeting cards. Just tell me. Don't think of any other permutation. It is just basic general knowledge. If I say I have 5 classmates. Let us say there is only a class with 5 classmates. 5 students. If this person wants to give a greeting card, to how many people does he give? 4. Yes. Have a look. Second person, remaining 4. Third person, remaining 4. Fourth also 4. Fifth also 4. So what does this mean? Each person will give greeting cards to the remaining 4, leaving him. Right? What does this mean? 5 students, each student giving 4 greeting cards. So it is nothing but 5 into 4. Right? Similarly, here we have 30 students. Obviously, each and every student will give 29 greeting cards to everyone, right, except he himself. So obviously, we will write it as answer as 30 into 29. Isn't it? What is the answer here? 9 3s are 27, 3 2s are 6, 7, 8, 870 is the answer. Isn't it? Hope you got that logic. Fine. Nice. Look at the next question. Find the sum of 4-digit numbers that can be formed using digits 0, 2, 4, 7, 8. So what was the formula? N minus 1 PR minus 1 sum of digits, the 1 1 1 up to r terms. If 0 is not included. What if 0 is included? We have to minus n minus 1 PR, again same story. Right? Did you understand? Fine. So shall we directly substitute and do the formula? See here. What is r here? R is 4. What is n? N is 5. So what is the formula now? The sum is equal to n minus 1 PR minus 1 into sum of digits. Okay. into 1 1 1 and so on up to r times minus n minus 2 pr minus 2 into sum of digits into 1 1 1 1 and so on up to r minus 1 times. Is it right? So let us substitute it now. Now just tell me what is n? 5. 5 minus 1 is 4p, r minus 1 is 3 into sum of digits 2 plus 4 plus 7 plus 8. 8 plus 2 is 10, 10 plus 7 is 17, 21. Okay, into 21 into 1 1 1 1 up to r times, that is 4 digits, so it is 1 1 1 1. Right? Fine. Minus n minus 2 pr minus 2. 4 minus 2 is 3p. Again, what is n? 5 minus 2, right? Yeah, it is 3. r minus 2. 4 minus 2 is 2 here into sum of digits is 21 into 1 1 1. r minus 1, since it is 4, 4 minus 1 is 111. Clear? Did you understand? Fine. What is 4p3? 4 factorial by 3 factorial. Can I write as 4? Yes. Why? Just see here. 4 factorial can be written as 4 factorial by 4 minus 3 factorial, which is nothing but 1 factorial. Sorry, it is again 4 factorial. 4 3 2 into 21 into 111 minus 3p2 can be written as again 3 factorial. 3 factorial, 3p2 can be written as 3 factorial by 3 minus 2 is 1 factorial. That is nothing but 3 factorial, which is 3 into 2 into 21 into 111. 4 3s are 12, 12 2s are 24 into 21 into 111 minus 6 into 21 into 111. Now just tell me, what do we get by multiplying all these numbers? We get 559944 minus 13986. So if I subtract these both, what is the answer I get? Okay, this is the answer we get after subtracting these two numbers. Is it clear? What did we do here? Just we substituted whatever the given information here, just we substituted in the formula and just simplified and multiplied. Clear? Without knowing the formula, can we do this? Obviously no. So it's better we have to remember the formula. Clear? Fine. What all we learned today? We started with what is permutation and combination, then we did few problems of NPR, then we did few this kind of theoretical problems. We learned this formula and we did this problem. Clear? Fine. Remaining things we'll do in our next session. This is for today. Let us meet in the next session with the more problems of permutations and combinations. Thank you.